Welcome back to What You Will Learn. My name is Adam Ashton.
And my name is Adam Jones. Today we're taking you through the best bits of the structure of scientific revolutions by Thomas Kuhn.
Thomas Kuhn says that his version of how science developed is pretty different to how most people saw it. This is written 60-odd years ago. He says that most people saw it as just some kind of slow, gradual, steady, cumulative progress where it's kind of like building a wall. You add brick by brick by brick until you eventually get to somewhere. Whereas he says, no, it actually isn't quite like that. It's very normal for a hell of a long time, and then there's some kind of discontinuous leap. There's a revolutionary phase where all these people have plunged into absolute turmoil and chaos, and eventually some new normal boils out of it.
Yeah, so he jumped up in the helicopter and looked at science from that 50,000-foot view and really pulled it apart. And it's very hard to look at science the same way after coming across this book. And in 1962, when this book first came out, it was very controversial because it really challenged the most powerful and entrenched assumptions about how science really works and how it really should work.
He said that all this scientific progress and discoveries go in sort of a cycle of two different phases. The first phase, he called it normal science, which is kind of like just the business as usual, day-to-day stuff. He says in this phase, you got all these community of researchers. They've got this common intellectual framework. He calls it a paradigm. They've kind of all been taught by the same textbooks and the same professors and the same teachers and following the same schools of thought. And they're kind of just chipping away at these little tiny things as part of their normal day-to-day stuff. To, if anything weird pops up, then it's their job to kind of make it fit into this traditional sort of school of thought.
Yeah, so this normal science is business as usual. It can be seen as probably analogous to a lot of things, not just the scientific realm, where when everyone's committed to a paradigm, that's all everybody can see. And then everyone focuses on fitting all their worldview and all the information around the world into that one little paradigm. But every now and then, something could just creep in that just doesn't fit in. And in your brain, you'll try and act like it's not there or something like that. But eventually, someone is going to take this thing that doesn't fit in and just go cray-cray, as Taylor Swift would say, on that paradigm, tear it apart, and then all of a sudden you're back to chaos.
That's it. Once they've tried to shoehorn in so many different little anomalies to this same one paradigm, or once something so big pops in that they can't possibly squeeze it in anymore, that's when they're like, okay, hang on, we better take a step back here and not just do our day-to-day mopping up. We better have a look at, is this paradigm even right, or should we be going somewhere totally different?
So this is where the paradigm shift kicks in, and it really happens after the scientific field returns to normal science, and then everyone just scrambles and finds the new paradigm, and there we go through it again. So in this episode, we're going to go through the phases of how science works, and as we were saying, you can look at this as an analogy. Of course, 7 Habits of Highly Effective People focused on the power of a paradigm. I think you were saying before, Ashto, Seth Godin refers to this book a lot, because what happens in science can happen in a lot of other areas of life, and the power of the paradigm.
So phase 1, our normal science, it's basically just following the textbooks. You've got a whole bunch of different facts. You've got specific methods that you've been taught as a young whippersnapper scientist coming up. The great scientists of history have really contributed to that knowledge. It keeps growing and growing and growing. All these, cumulative discoveries add to the pile. This normal science that you're doing is based on the stockpile of all the things that you've found before that add up to this, hey, this is how we do things around here. This is the paradigm.
Yeah, a lot of work goes into a textbook. If you've done your year 8, year 9 science, there's 300-400 pages of dense stuff. A lot of energy, and it should be respected, because there's a real hard road to get to the point where all the scientists in the community agree on everything, and to the point where they can actually put it in a textbook. Because prior to that, there was so much chaos. You didn't have a consistent paradigm around, so there was so many different facts and assumptions about the world and about the universe. Everything was equally relevant, and no one could agree on anything.
Yeah, that's right. All these different people throughout history were looking at different scientific phenomena and trying to explain it and trying to find reasons for it and trying to link them all together. And they really kind of described and interpreted them in different ways based on the way that they thought. But eventually they all kind of work it out and come to a point where they're like, well, we can't just all be off doing our own things. We've got to kind of create some kind of general consensus here, probably a bit of fighting and probably a bit of politics behind the scenes and stuff. But eventually all these discrepancies between the different ways of thought kind of converge to this one consensus approach.
So in the pool of information, you got this infinite facts, and that's where the issue is, because you got too much stuff for everyone to work anything out because you're not focusing on anything. And that's what a paradigm does. You get the spotlight and you focus on one part of the pool of information. And for that period, everyone's just looking at that pool and forget any of the previous ideas existed.
And so eventually that's where they say, okay, all this crew of people, we're chemists. We're going to follow the chemist paradigm. And then there's another crew that says, hey, we're physicists, we'll follow the physics paradigm. Another group of biologists, they'll follow the biology paradigm. They're all kind of zooming in on their own little unique special parts of this massive pool of information.
So I don't know really, the difference between how a chemist and that physicist look at something like helium, but apparently they look at the same thing, they look at the same information, but because of their paradigms, one calls it a molecule and one doesn't. So it's just showing their background of their paradigm, of their profession. They're seeing totally different things, even though they're looking at the same thing. If you think about 7 Habits of Highly Effective People, if anyone's read that book, at the very start, there's a picture of well, depends how you see it. You could look at it one way and it's an old, scraggly looking lady, someone who you wouldn't, if you're a heterosexual male, you wouldn't want to go out for dinner with that one sexually. But then there's... don't know where this is going. But if you look at it a different way, it's a really beautiful and attractive lady as well. But the same information, but the paradigm makes you see a totally different picture.
That's right. Depending on what glasses you're looking through, I guess, how you see that picture. It's kind of like if a chemist looks at an atom of helium or a physicist looks at an atom of helium, they both instantly, without any hesitation, without any confusion, they know exactly what they're doing and they've got their own ways of looking at it, even though they're both totally different.
So this commitment is a prerequisite for normal science. It'd just be too hard to commit to something without it. And it's got a big upside having this paradigm because you get to solve real issues, right?
Well, so what happens is that if you say, yeah, I'm a chemist, I'm going to follow the chemist's way of thinking, and you're welcomed in by the older chemists and you're part of the crew now, all the work that you're going to do is going to be following the chemist's line of thinking, and you're going to go out there and solve these little problems and little puzzles that pop up through the chemist's lens.
Well, that's it, yeah, because you got a spotlight, a focus where you can all agree upon. You can solve real issues, but there's obviously going to be blind spots in your paradigm, and a lot of the time you're just performing mopping up operations where some issues pop up that go against the paradigm, and you just find ways to solve it and sort of shoehorn it back in.
Yeah, that's right. It says that a lot of science really is just mopping up. When something, a lot of the time you're just going away and you're finding exactly what you expect to find, and then you do a little experiment and something slightly unexpected will pop up. You're like, oh, that's a bit strange. And then you just find a way to mop it up and make it fit.
Yeah.
Say, maybe I must have done something wrong. Let me run this again. I'll ignore the first one, and you find a way to make it fit.
Yeah, that's it. And you can see why in 1964 this was a big finger up to the scientific community, because he says here most people throughout their whole entire career just engage in mopping up activities. They're not really proper scientists. They're just holding a mop and trying to fit things into a paradigm.
That's right.
And probably holding progress in some ways.
Yeah, you're not going out and discovering brand new elements that nobody's ever seen before. You're just trying to find ways to make those weird little, ever so slight anomalies, make it fit into the way that everybody else is thinking.
But altogether, professionally, it solves problems that previously to this paradigm, they couldn't even imagine what they could have undertaken with getting the spotlight and focusing on this pool of information and solving things, and everyone committing to this one paradigm.
Yeah, it makes sense that you got that massive infinite pool of all this weird shit that's going on. You're never going to be able to solve everything until you get that spotlight and focus, go deep, get dirty into that pond, and you work out a few things. And all these discoveries have come because of all these people focusing narrowly and deeply on their specific niches.
But as Kuhn writes, the most striking feature of the normal research problems that all the scientists out there are working on we encounter is how little they aim to produce major novelties, conceptual and phenomenal. What he's saying here, Ashto, is not many people out there are working on the big stuff. They're not going to try and bring the next Einstein sort of revolution. They're working on little issues in their whole career.
So as we were saying, a lot of the time you're doing your normal science, you're finding these slight incremental discoveries, you're kind of solidifying what everybody else already thought, and your experiments are proving that. There might be a few little things pop up, a few little weird discrepancies, a few little weird anomalies, but hey, it's your job to mop them up and make them fit, and you kind of maybe expand the scope of the paradigm slightly. Maybe you kind of change your experiments, and maybe you fudge your data a bit to make sure that it fits. Maybe not. Maybe they're doing some real science. Maybe they're not just making up numbers. But, there's slight discrepancies. They're going to creep in, but you're going to make them work.
So the novelty here runs counter to what's expected. And this is what he calls the anomaly. And this is where all the new discoveries are really commenced. So it's by focusing on the anomaly somewhere. And this is just a recognition that somehow this anomaly is violating the paradigm in a really big way, and it goes against the normal expectations that govern normal science.
Yeah, it's a different way of looking at it. A lot of the time, the scientist is just going to be like, oh, there's an anomaly. Either I'll pretend it didn't happen or I'll make sure it fits. Whereas sometimes the scientist will come along and be like, oh, that's an anomaly. We should take a bit of a second look at that.
That's it. There's a few scientific experiments that shows exactly how the human brain works in this. In the case of playing cards, and this study was conducted by the famous Bruner and the postman. Not the local postman, but I'm guessing it's a surname, not postman.
Probably Simon Postman and Johnny Bruner or something.
Simon the postman, yeah.
What they did was they had a whole bunch of playing cards. They asked people to memorize them. They weren't actually testing their memory, because what they did, they just slipped in a sneaky card so that you just have a normal, you got your king of clubs, you got your two of diamonds, and then all of a sudden they slipped in a six of spades, but it was red. Most six of spades are black, but it was a red six of spades. And they were kind of just testing, what are people going to do? If there's this little anomaly here, what are they going to do? A lot of the time, people just didn't even notice. They just incorrectly said, hey, that's a six of hearts, because they saw kind of the similar sort of shape as a heart. It was red, so they just said, oh yeah, there's a six of hearts, even though it was a red six of spades.
Well, just naturally, when you're flicking through the cards, you're committing to the preconceived paradigm that all six of spades are black, and that's all you see. So the brain actually doesn't pick up the anomaly. So, in this experiment, all cards were identified and usually correct, but the occasional anomalous card pretty much always missed, and they go through it without hesitation.
Every so often, you might have someone that says, oh, hang on, this is a six of spades, but there's something wrong with it. It's like a black card with a red border or something, which was like the brain's doing weird things there, because it was definitely just red, but they were saying it was kind of black with a red border. But so your brain, some of those brains are kind of trying to work to fill in the gaps. They know something's not quite right. They're still trying to mop it up.
So that's when the scientists showed them and said, hey, here's the card.
Yeah.
And then they sort of shut themselves. They're like, oh, there's something wrong with that card. I just can't really put the black has a red border, and they can't figure it out. And then obviously further increase of the exposure without hesitation eventually produces the right identification without hesitation.
There was this period where people are like, well, I don't even know what this is anymore. What even is a spade? Is a spade black? Is it red? What's a heart again? And I don't even know what these cards are anymore. Like, there's this real turmoil going on until someone is able to clear it up and say, hey, yeah, we've snuck in a little. There's such a thing now in this deck of cards as a red spade. So once people know what to look out for, they're like, okay, so that's my new paradigm.
So in the development of any science, the first received paradigm is usually quite successful, and you're flicking through the card deck and you're actually picking up things that are mostly right, and you don't even recognize the thing that are wrong. And if you see the wrong thing, you start shitting yourself and trying to fit it into the old paradigm. But in the case of science, at the very start, the equipment that you've got for the paradigm of the time, it all fits in. But over time, you get better and better equipment, and even the vocabulary you use, you start having new words that pop up that to describe things. And as you start zeroing in with new vocabulary and better equipment, the anomalies start becoming clearer and clearer. It's like the redness of the black spades slowly starts to come out. Then it becomes harder and harder to hang on to it when the experiments are confirming all these issues.
That's right. I suppose this is a totally made up one, but if you're going back a couple of 100 years, and imagine the types of, you're starting out with this magnifying glass, which is probably just a pretty basic sheet of glass, and you're looking at a rock, and you're like, yeah, that's just the same rock as all the other rocks. Eventually, if you get a better and better microscope, you can zoom in a bit, you got super high definition, you're like, oh, this rock's totally different. Once science kind of develops, once they've developed both their vocabulary, their understanding of different things, you've got better equipment, suddenly you're realizing, oh, all those rocks that I thought were just the same rocks, there's actually 50 different types of rocks out there.
Yeah, 100%. Well, another one, think about like before the scientific revolution, you had everyone just thought the church, God just did everything. God, it's all about the Bible. Then was it Galileo with his telescope? I think
He had something.
he sort of spotted the red card that that the Earth isn't at the very center of the universe. We're actually revolving around the sun. We're part of the universe, and he sort of like the big red card was that not everything revolves around the church, and this is really what did spur the scientific revolution, where a whole new paradigm emerged and the old one broke down, and then all those new inventions and discoveries happened, and perhaps that's how what led to the world we are in today.
Yeah, it is interesting to note that generally the types of people that come up with these, they do analyze the anomalies, they do go deeper, they do spot that red spade that's not quite right, doesn't fit with the rest of the others. They're generally very young, as in early in their careers, or there's someone from a different field who's got a different perspective, which kind of makes sense. It's not the 65-year-old who's been doing the same thing the same way their whole career. It's somebody with a new and different perspective that pops in and is like, oh, hang on a sec, should we have a bit of a deeper look at this?
Oh, mate, you'd be pissed off, wouldn't you? If you're a 50-year-old and you've spent 20 years putting together one of those insane textbooks, how's the sunk cost there? And then some little whippersnapper comes in and just pokes holes through it, through the anomalies. You're not going to be happy about that.
Not at all. So it's understandable that the revolutionaries are usually young. They're not the entrenched ones. As you say, well, if you've done a textbook, you're not going to be like, oh, hang on, maybe I got that one wrong.
Yeah, no way. So it does fit a bit of the stereotype he says here, because a lot of the time, the whippersnapper, either they're being young or they're from a different field entering a new field, they see the anomaly and, at night time, they're just like, something's just not right. And in the middle of the night, they're deeply immersed in crisis and they figure it out. If you think about Einstein, he must have been deep on an anomaly at the very start when he came up with his thought experiments when he traveled with the speed of light. And then when he was traveling at the speed of light, he saw the anomalies in Newtonian science and, came up with the green shoots of quantum physics, which destroyed all of Newtonian science and came something new. But you could imagine that didn't happen overnight. I think I read his biography a long time ago, and at first, his first papers, no one really looked at it. And then over time, people saw the issues and then, came on board with him.
Led by this new paradigm that's come along, scientists generally now they're looking in different places. I suppose they're, exploring different parts of that pond or that pool of knowledge that they hadn't looked before, probably looking with new instruments, new ideas, new approaches, and all of a sudden it feels like they've been off in some completely other planet. Things are completely unfamiliar to them. They're looking through a different lens with different light at all these unfamiliar objects. It'd be pretty scary as a 65-year-old entrenched scientist who had only one way of doing things.
Oh, that's it. So previously things were ducks, now they're rabbits. Before you're looking from the box above, and now you're looking at things from the inside. So transformations like these, they're usually pretty gradual, but almost always irreversible. For the scientist's perception of the new environment, everything must be re-educated. Those poor textbooks everyone put together, they're not really working anymore.
It is kind of like those people they torture with those weird playing cards. Once you know what's going on, you can spot these. Originally, when you didn't know what was happening, you were kind of blinded to what there was. As soon as you know that there's a weird different card out there and you've kind of understood there's a different thing, your paradigm's changed, that you can now understand this, you're going to see those all the time now. Yeah. It's not going to trip you up anymore. You're going to be smack bang. There's that weird six of spades that's actually red again.
Well, it goes through that whole process at the very start. You can't see shit because you're just seeing through the paradigm. You go through the moment of crisis when you're shitting yourself. And then thirdly, you're actually seeing through the new paradigm and you're picking up all the anomalies quite easily. Pretty similar story when it came to the discovery of Uranus, because before 1690, everyone had seen what Uranus was doing. It was very different to stars. It was pinging around the universe much quicker. And it was 17 times between 1690 and 1781. What's that, 90 years? A lot of astronomers saw these anomalies and recorded it, but actually didn't focus on it and then let that lead them to a revolution.
Yeah, that's right. They let that one slip. There was even one period in 1769, the same person 4 nights in a row saw this thing that they saw it was a star, but they knew it was doing something different, but they thought, oh, it's probably just some kind of weird star, or they thought, oh, maybe it's a comet. It's either a star or a comet, but let's just let it be. Basically, They didn't think too much further.
So William Herschel, he's the one who came in and he saw the anomaly, the same object 12 years later. Something was a bit weird about it, and after several months of fruitless attempts, he said it's a cometary orbit, so it's a comet. But then he kept looking at it, and he was like the red card, just eventually just looking at it, and then he finally landed on that it was a planet, just like the card. And then after 1781, there was a new perceptual category of what was out there in the universe.
Yeah, Big Hirsch, he'd made his own telescope as well, which ties back to what we're saying about getting better and better equipment and apparatus. He'd made this telescope that was much better, and he could see like a bit of a disc around it. He could kind of see a different shape to what he was expecting. And once he'd finally said to everyone, hey, this is a planet, then all of a sudden, actually all the other astronomers were like, oh yeah, you're right, that is a planet.
Yeah, and that shift of your vision enabled astronomers to see Uranus, and then also started looking out and see all the other anomalous red spaded sixes or whatever. And because this new paradigm, it meant they actually forced to look out for more planets. And of course, pretty much straight after that, there was an explosion in the discovery of planets. So they found 20 of them in the first 50 years after the 19th century.
How many planets we got? I've only got 9 or 8 now. They must have found a few extras.
Maybe there was another paradigm that came after that wiped a few of them out. Well, it's true, right? Pluto.
I suppose there's some big-ass moons and stuff that maybe they thought that was a planet or something.
Probably, yeah. Well, Pluto, at one stage in the paradigm, was a planet.
Yeah.
And then he got the boot.
Only what? Like what, 5 or 6 years ago?
Is it the size or something?
I think it didn't have the strength to pull shit into its orbit or something.
I reckon it's a planet, man. In my brain, it's a planet.
Mate, you're stuck in seeing that red spade thinking it's a heart. Mate, it's a spade.
Mate, all these young whippersnappers changing the paradigm. Need to do something about them. But what happens to these old folk like me who think Pluto's a planet? Darwin wrote about people like that. He said that there's no way he thinks he can convince experienced naturalists whose minds are stocked with multitudes of facts all viewed during a long course of years from a view directly opposed to mine. So he's saying, I can't convince those old people. And even Max Planck wrote, a more brutal version, a new scientific truth does not triumph by convincing its opponents, so they're not going to try and convince the oldies and making them see the light, but rather those oldies, they're eventually going to die. And when they die, the new generation, they're going to be on board with the new paradigm.
Oh, Planky. He didn't hold back, did he?
No, he didn't. Well, it's very true, and isn't it?
He's not going to bother. He's not even going to try and change it. He's just going to wait for him to die. Yeah. And then he'll just take over.
Yeah, geez.
Planck's
constant.
So in summary, it probably seems somewhat not that amazing today, but 60 years ago, this was an amazing discovery, I guess, where Thomas Kuhn says that science doesn't make those smooth, gradual progress and slight additions that we kind of thought, building a wall of knowledge brick by brick. Often it's a whole bunch of normal stuff and then out of nowhere, some kind of revolution that completely changes things until you get back to a new normal.
Yeah, I think the big takeaway from this one is whatever you're doing, a scientist or you're in a field or anything, you've really got a choice to be a mopper for your whole career, just grabbing the mop and mopping up everything and shoehorning stuff. Or you can actually be someone out there looking for the anomalies and look for those red playing cards, because if you find them and you focus on them, only then you can actually revolutionize science or an industry or anything like that.